In this video, we will give you an overview about gut microbiota. The Earth was formed about 4.5 billion years ago. And about 1 billion years later, that is, about 3.5 billion years ago, the first bacteria appeared on Earth. It was not until 3 billion years later, that is, approximately 485 million years ago, that green algae conquered the Earth and became the first plants on Earth. The earliest known reptiles date from about 315 million years ago. Dinosaurs originated about 245 million years ago. About 205 million years ago, the first mammals appeared. While humans with modern anatomical features arose between 300,000 and 200,000 years ago. Bacteria therefore appeared on Earth long before any other living being and have persisted to the present day. This evolutionary success is largely due to their great adaptability. We can find bacteria in the most inhospitable environments on Earth. There are bacteria that live at the bottom of the oceans where light does not reach, in areas with extremely high temperatures such as volcanoes, or extremely low temperatures such as glaciers, as well as in areas highly contaminated even by radioactivity. The great adaptability of bacteria has allowed them to be able to also live on other living beings, with which they establish a mutually beneficial relationship called symbiosis. That is, bacteria benefit from living in living organisms while also providing a benefit to the organism on which they live. For example, there are bacteria that live in the roots of some plants, where they help to solubilize and capture nutrients. In the digestive system of some marine animals, where they help digest the chitin of the crustaceans on which they feed. In the digestive system of some birds that help to neutralize toxins present in seeds. Or in the digestive system of animals such as camels that help to ferment cellulose. And bacteria also live on us human beings. We have bacteria living on our skin, in the respiratory tract, in the mouth and gastrointestinal tract, and in the urogenital tract. On the skin, which is our first defense barrier, many bacteria live that help us in this defense. Behind our ears, we have more than 2,300 species of bacteria, and in the inner part of the elbow, more than 2,000 species. Here you can see the bacteria that we have on our feet that are responsible for the characteristic odor that our feet have. There are also bacteria in the respiratory and urogenital tracts. In the respiratory tract, specifically in the nostrils, we have more than 2,200 species, and in the throat, more than 4,000 species. While in the vaginal opening of the urogenital tract, we have more than 2,000 different species. Finally, we are going to talk about the bacteria that live in the gastrointestinal tract. There are bacteria throughout the gastrointestinal tract. For example, on the tongue, there are almost 8,000 different species of bacteria. The part of the gastrointestinal tract with the highest number of bacteria is the large intestine, where one finds more than 33,500 species. These bacteria are known as the gut microbiota. And what are the main characteristics and functions of the gut microbiota? The gut microbiota represents 90% of our entire microbiota and consists of 38 trillion bacteria that weigh between 500 grams and 2 kilos. The intestinal microbiota has important functions in digestion, in defense, in gut-brain communication, and finally in the education of the immune system. The large intestine or colon, where the gut microbiota is, receives remains of food that we cannot digest in the small intestine. These food remains can be digested by bacteria of the microbiota by a process called fermentation. During fermentation, the bacteria produce substances such as vitamins and short-chain fatty acids that are beneficial to our body and are therefore absorbed and passed into the blood. The intestinal microbiota also plays an important role in our defense, since by occupying the surface of the intestine, they prevent pathogenic bacteria from growing there and entering the bloodstream. The intestinal microbiota can also influence the communication between the gut and the brain. The vitamins and fatty acids produced by the intestinal microbiota can influence the production of neurotransmitters by the enteric nervous system and therefore the information that reaches the brain. In addition, the intestinal microbiota itself can produce neurotransmitters which, if passed into the blood, can directly access the brain. And gut-brain communication affects our subconscious. So the gut microbiota can influence the perception we have of stress, of emotions, of pain, or of fatigue. The influence of the gut microbiota on our subconscious, and therefore also on our decision-making, could be much more important than people can imagine. There are researchers who consider that bacteria live on us in a relationship similar to the one we have with the planet Earth. However, other researchers consider that we are not the planet of bacteria, but rather a vehicle for bacteria, and that they direct our behavior based on their interests. This idea is based on the peculiar behavior of a cat parasite called Toxoplasma gondii. The definitive host of this parasite is the cat. Toxoplasma gondii infects and reproduces in the gut of these animals, which is why it is present in the feces of infected cats. The intermediate host of Toxoplasma gondii is the mouse. When the mice come into contact with feces from infected cats, they become infected, and later when the cats eat infected mice, the parasite manages to infect new cats. There may be other intermediate hosts, including man, but they are considered accidental. Toxoplasma gondii in mice infects the brain, unlike it does in cats. By infecting the brain, this parasite is capable of changing the behavior of mice, making them not only lose their fear of cats, but also feel attracted to them, which makes it easier for them to be hunted, and therefore for the parasite to gain access to their habitat, the definitive host. Finally, the intestinal microbiota is also relevant in the education of the immune system. During our first years of life, contact with pathogens allows an adequate education of the immune system with a balanced development of pro- and anti-inflammatory effector lymphocytes, which translates into the development of an efficient immune system. If for some reason, such as excessive hygiene or lack of contact with other children, the contact with pathogens during the first years of life is reduced, the balance between pro- and anti-inflammatory lymphocytes may be altered, and this may result in the development of allergy and autoimmunity. In the same way, the gut microbiota and the short-chain fatty acids produced by these microbiota seem to be relevant in the development of regulatory immune cells, and therefore in the development of an efficient immune system. If the gut microbiota is poor, the production of regulatory immune cells can be reduced, and consequently the risk of developing allergy and autoimmunity can be increased. And these are the main functions of the gut microbiota.